What's up guys, Matthew Monas here. So the other day, a friend of mine in the filmmaking industry reached out and said, hey Matt, I need your expertise. I need you to upgrade my PC and build me something that will help ingest footage super fast, edit it like butter, be powerful, but most importantly, reliable. Now, of course, this build doesn't come cheap, but I wanted to share this with you because who doesn't like a really good workstation build? So first up is the case, and I wanted to make this thing a very clean build. It's not for gaming, it's purely for getting work done. And hey, if it looks good, then it's just a bonus. I've gone with the Phanteks Enthoo Evolve ATX. It's clean, it's sleek, has enough room to add things like capture cards, network cards, the list goes on. And as a bonus, it has tempered glass side panels for added looks, which is never a bad thing. Powering the entire setup is of course none other than the AMD Threadripper. It's the best priced performance CPU out there right now for workstations. It's the 1950X, comes with 16 cores and retails for $900 US. The Intel equivalent is the i9-7960X, which costs $1,700. You're paying huge for only 15 to 20% performance gains. When it comes to editing, grading, and 3D work, CPU is still king, and there was never any doubt in my mind that the 1950X was going to be a bad choice. Keeping the CPU cool, I decided to go with the Noctua NH-U14S air cooler. From my experience, air cooling is currently far better on the TR4 platform, and I wanted to give them something that will keep it cool, but also just be more of a workhorse. Now this is going to be placed down and just put to use. There's going to be little to no tweaking of the system once it's in. It just needs to work. The Noctua cooler only comes with one fan, so I added one more for a push and pull system, and this made a huge difference. Under load, we reached temperatures of 54 degrees Celsius, and this is running on stock frequencies. Now, even though this system won't be overclocked, we can get up to 72 degrees Celsius at 4 gigahertz, which isn't too bad. So this whole build is using the Gigabyte Aorus X399 Gaming 7 motherboard. The main reason I chose this was largely down to the fantastic mix of expansion slots and ports for connectivity. Not only does it have 8 RAM slots, there's space for 4 double-width GPUs for future expansion. Plus, add 2 shielded M2 slots, 10 total USB ports, built-in Bluetooth and Wi-Fi, and a legacy PS2 port makes this a great all-around motherboard for the work environment. When it comes to video work, it's a careful blend of finding the right components. Memory is a huge one that can make massive amounts of difference when working with memory-hungry programs like After Effects, Premiere, and Resolve. I knitted it out with 128 gigabytes Vengeance kit from Corsair. They strike a good balance between speeds, as the official supported speed of the Threadripper platform is 2,667. And of course, putting anything more can potentially void the warranty. As a workstation build, we want to adhere to the warranty whenever possible. This is all about stability. These also had the perfect height to fit ratio for the air cooler. Everyone always goes on about having the best GPU and CPU, but when it comes to workstations, I found storage makes the biggest difference when it comes to day-to-day usage of video editing and grading programs. And oh boy, I did not skimp out on it. There are a ton of brands with a few notable ones that focus on video professionals, but there's only one brand that comes through all the time, and that's Angelbird. We have 5 of their 2 terabyte AV Pro XTs and RAID 0, and they have drives that go to 8 terabytes. But right here, we got 10 terabytes of super fast storage. It's extremely quick too. The goal for video editing is looking at sustained write speeds, dealing with large incompressionable data. Sequential high speeds can be good for system and OS use, but for performance, it's all about the sustained performance. Look, I considered going with NVMEs, but the limitations would be astronomical, not to mention some technical limitations. These aren't cheap either, but the video-specific features of these Angelbird drives are worth the price of entry. There's adaptive thermal protection, which monitors the temperature and adapts to optimize the write speeds in real time to make sure it's always running at optimum. But my favorite is host power protection. What this essentially means, if there's power loss, it flushes all the data and writes it down before shutdown. There's a ton more which make it perfect for this build, and it's going to be awesome for this project. The hardest decision for this build was the GPU. After much deliberation, the right GPU for this build was the AMD Vega 64 liquid cooled, with the main reasons being 10-bit color support out of the box. Unlike Nvidia, we have to actually go out and buy a Quadro card, which, let's face it people, is insanely priced. Also, I found AMD cards to be more stable, with most of my errors being GPU related when it comes to programs like Premiere and Resolve. The OpenCL standard supports a wide range of plugins and software due to its open nature. Overall, these cards fall right in line between the 1080 and GTX 1080 Ti. Now, when it comes to performance and stability is the name of the game, then the power supply has to be one of the best in the business. Seasonic have always stood out to me and are extremely highly regarded, so it was an easy decision to go with their latest 1000 watt Prime. It achieves the higher level of 80 plus titanium in the current configuration. We have a large overhead, but I know this system will be expanded in the future, so I felt it was a good time to do it. It's fully modular, so this keeps it clean, and it has a hybrid fan control. This keeps the fan from spinning until 50% load, which makes this one quiet machine. This is such a good PSU, and it's one of those components that can easily be skimped on, only to bite you in the ass in the future. Okay, performance. This is where things get very interesting. My perception has always been that NVIDIA GPUs are usually superior when it comes to video editing. But based on my test results, I was quite surprised on how well the Vega 64 liquid-cooled performed. In the majority of video-related tests, the Vega 64, GTX 1080, and 1080 Ti came neck and neck. Even with rendering, they all maintained similar scores. It wasn't until the warp test that we noticed the biggest difference. The Threadripper with the Vega 64 performed a warp test 10 minutes faster than the Threadripper using a GTX 1080 or 1080 Ti. Even in DaVinci Resolve, the Vega 64 surpassed the NVIDIA cards. It really wasn't until we actually gamed that the NVIDIA cards pulled ahead. In fact, all the games we tested, the Vega 64 liquid cooled either tied or beat out the GTX 1080. The 1080 Ti, on the other hand, is still the king when it comes to gaming, beating out both cards with frame rates that were 20 to 30 higher. But what makes this even more interesting is when we put these cards in a 4-core 7700K PC. As we expected, the rendering time significantly increased by more than double. This is normal since it has less cores. However, when it comes to stabilizing footage, the 7700K PC destroyed the Threadripper. This shows that higher clock speeds are preferred over more cores. This is the thing though, if you plan on stabilizing multiple clips at the same time, the Threadripper PC will do a much better job, as you're forcing a program like Adobe Premiere to make use of more cores. Gaming benchmarks favor the Threadripper build, which is quite surprising. Just like with the Ryzen, I was expecting the 7700K to be no different. But frame rates were higher using all three cards. The only time the 7700K came ahead was with the game Deus Ex Mankind. So here are my closing thoughts. We built the perfect PC for their situation. This thing is fantastic for video editing, especially when you consider the price point. It's reliable, it's sustainable, has great performance, and in the future, if they want to upgrade it, they can go ahead and do that. I was also very surprised on how well the AMD 64 liquid-cooled GPU performed. Not only did it surpass NVIDIA in certain situations, it did the same job in video editing, sometimes even beating it out. So that wraps up this build. Let me know your thoughts in the comments below, and if you want to see more builds like this. If you did, hit the like button. If you're new to the channel, subscribe, and I'll talk to you in the next one.